In this lesson, we're going to further extend what we started with imaginary numbers the last lesson and talk about complex numbers. Now, we are not really introducing a new number system. We just call the complex number system this number system. So if this is the complex number system, that contains both the real number system and the imaginary number system. So we have real numbers like 5 or square root of 2 or 1/2. We have imaginary numbers like 5i, 6i, 2i. When we talk about a complex number, basically we're just saying that has a real component and an imaginary component. So 5 plus 2i, those type of numbers would be kind of out here, okay? Because they're not pure real and they're not pure imaginary. They have a piece that's real or a term that's real and a term that's imaginary. So this is basically what I just described here in this paragraph. We can't combine the real and imaginary part like 5 and 2i. One, they don't look like terms, and secondly, they're kind of in these different number systems. So our first problems are just finding sums and differences. It isn't really necessary to put these parentheses around these two because we're adding, we're not multiplying, but that's saying this one complex number, -2 plus 7i, is added to this other complex number, 6 plus 2i. When I add those together, I just combine my real parts. So I combine -2 and 6 and get 4, and I combine 7i and 2i, and I get 9i. Now the only power of I have here is I to the first, which we know is just I, so there's none of that exponent simplifying like we did last time. Here my imaginary components of my complex numbers have x's, that's fine. So I have 20. We can add in ones just like always, so 4xi minus 1xi is 3xi. Here. The next one has subtraction, so just like we've done all year, we have to distribute that negative sign. So this one becomes 5 plus 3i, and I'm going to drop the parentheses, minus 2 plus 7i. So we have 3 plus 10i. Last one. So distributing, I have -3 plus 5i plus 8 minus 2i. So we have 5 plus 3i as our final answer. So all of these answers are complex numbers. They have a real part and an imaginary part. Here's a multiple choice question that's very similar. So I'm adding these two complex numbers together, right? Sum. So we get -2 minus 3i here when I combine those together. Probably a more common problem you're going to see because it brings in some of those properties of imaginary numbers is multiplying two complex numbers. Now, one thing you'll also notice is usually if you have an x, we would write this as 5x plus 3. When we write complex numbers, we always write the real part first and then the imaginary part. That's called standard form for complex numbers, so that's a little different to get used to. So here, just like as we said, I works like x's until we get to exponents. So here's my distribution. I have 21 plus 6i plus 35i plus 10i squared. Now when I get to here, here's my I squared. From the last lesson, and if you haven't watched that, I would suggest watching it first, I squared, the square root of -1 squared, just equals -1. So I need to plug that in. I'm also going to simplify as I go along. So this is 21 plus, combining like terms, 41i. So this is 10 times -1 here. So what I end up with in terms of the real numbers is 21 minus 10, right? Because that would be -10 if I simplified that. So I get 11 plus 41i. So here's my 11, 21 minus 10, and then I already had the 41i. I'm going to make this a little bigger so I have a little more room to write for the next one. So on this next one, just draw this line, we're going to distribute, and I'm going to do this one a little faster. So I get negative 6 plus 4i, and then plus 18i minus 12i squared. When you know it's coming, you can save yourself some time, so I can cross out this I squared and make sure you're in parentheses write negative 1 here. So this is negative 6 plus 22i. Negative 12 times negative 1 is positive 12. So this is 6 plus 22i. The last one, so I get negative 20 minus 12i minus 5i minus 3i squared. There's my negative 1, so I can cross it out. And if I can do this in my head, that's fine. So this is negative 20 plus 3. You need to acknowledge that you are replacing the negative 1 for the I squared. So negative 20 plus 3, this is going to be positive 3, is negative 17, and then you have minus 17i. So that's your minimal amount of work on that one. Now, we're going to look at something that happens, and this is shouldn't really be surprising, when we multiply what's called complex conjugates. And those are two complex numbers where one's a plus bi and one's a minus bi. We're kind of expecting something to happen because we know that this looks like that difference of perfect squares, which when we have x's does give us something with canceling those middle terms. So let's just see what happens here. So I have 25 plus 35i minus 35i, and then I get minus 49i squared on those last two. So these middle terms do still cancel as we expected. If I replace the I squared with a negative 1, I'm going to end up with 25 plus 49. So imaginary numbers are gone, which makes this even more interesting than if this was just, 5 or 7x plus 5, 7x minus 5, right? Because now we have those imaginary numbers. So we just get 74. So quickly going through the other ones. Here, be careful, this is minus x squared, I squared. They're both squared, right? Because we have xi times xi. So middle parts cancel. I get 100. This is basically going to flip to positive because the I squared is negative 1. So that's plus x squared. Now here, this is real, right? If I want to switch it up, I could write it in standard form, right? It's just an x, so the x goes first. Don't worry too much about that. But this is all real numbers as long as we assume that x is a real number. And that is actually one of our rules. If we go back up here, when we have a complex number, we're assuming that a and b, so the a and then the coefficient of I, are both real numbers. So the last one, a little different looking because those first terms are negative, but we should still get the same thing. So we have 9, and that's 64i squared, so 9 plus 64 when I flip this over to negative 1, which is 73. So the next question says, what is true about the product of two complex conjugates? When I look at each of my answers, we see that the answers are just a real number. So the product is a real number. So this is another time, just like we saw with those I squared or I to the fourth or any of those even powered or even powers of I, that the imaginary numbers go away and it's just real. Here, if I multiply these two binomials that are complex conjugates together, my answer is also a real number.